For my project, I decided to look at rising heat. Specifically, I looked at global monthly temperature anomalies as a proxy for global change and temperature increases. So let's take a little introduction to my data set. So I used a publicly accessible data set that compiles monthly global temperature anomalies from major sources such as NOAA and Berkeley Earth. So this is a little snippet of my data set. This is from the year 2017, and as you can see, the data set includes data from every month out of every year. In total, this data set covers 170 years of climate data from the years 1850 to 2023. This only shows 5 columns, but the data set includes the monthly anomaly, the monthly uncertainty, the annual anomaly, the annual uncertainty, and then the 5, 10, and 20-year rolling means for those anomalies. So my hypothesis with this data was that global temperature anomalies can be used as a proxy for global climate change. I think that the consistent increase across all of the months will suggest that the trend is not just seasonal variation, as a lot of climate skeptics believe, but rather a clear sign of global warming. So now let's take a look at my data. So the first graph that I made is a line graph with 12 different lines representing January through December, labeled as 1 through 12 on the right-hand side legend. So this data is shortened from 2000 to 2023 so that you can see the lines a little bit more clearly. And essentially, every value on the left, the temperature anomaly, shows how much warmer or cooler a month was compared to the 20th century average. And so this is essentially proving that this data can be used as a proxy for detecting climate change, because it proves that, or really it helps to prove that the warming is not seasonal, but rather it's systematic. So as you can see, no matter what the month is, there's a general upward trend. The next graph that I have is a histogram. So this graph represents 2,077 monthly anomaly values, and most of those values are falling between negative 0.5 and positive 0.3 degrees Celsius with a right skew that peaks around 0 degrees. So essentially with this right skew, this graph is showing that warmer than average months have become more frequent, which is a clear sign towards long-term global warming. The next graph that I did was a scatter plot. So each point or dot on the scatter plot is 1 month's anomaly versus its uncertainty, which is on the left. So as you can see, higher uncertainty often corresponds to older or cooler anomalies, whereas recent and hotter anomalies tend to have a much lower uncertainty. So essentially, this is disproving a potential argument that warmer temperatures have higher uncertainty, or we're not as sure about these anomalies, when actually we're more sure about these more recent warmer temperatures. My next graph is a basic line graph that plots the average anomaly over time. And so as you can see, there's a clear upward trend that reaches a specific, not peak, but it starts heavily increasing around the year 1980, which matches the timeline of rising industrialization and greenhouse emissions. And then my last graph is a heat map of the monthly global temperature anomalies. So this shows the anomalies by year on the left, or on the rows, and it shows the months on the bottom, or in columns. So when you first look at this, it can be quite intimidating, but essentially what this graph is showing is that in earlier years there was much cooler temperature across all months, or cooler anomalies, whereas in recent years across every single month we're seeing higher temperature anomalies, which visually proves that warming is not limited to those warmer months, and that it's not a seasonality trend that we're seeing in these temperature increases, but rather it's an annual, yearly trend. So yeah, this is just a citation. I received the data from